Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss least recently used page replacement algorithm. Least recently used page replacement algorithm, which is also called as LRU, keeps track of usage of all the pages over a period of time. This implies LRU keeps track of the way how the pages are utilized during the course of the program's execution. LRU works on the principle of locality of reference, which states that a program has a tendency to access the same set of memory locations repeatedly over a short period of time. So, pages that have been used heavily in the past are most likely to be used heavily in the future. So, the overall objective of LRU is to retain the frequently used pages while replacement is performed over the least used of the pages. So, here whenever a page fault occurs, then the page that has not been used for the longest duration of time is replaced by the newly requested page. So, this is the way how LRU performs replacement. Now let us go through some of the advantages and disadvantages of LRU page replacement algorithm. So the first advantage is that LRU does not suffer from Belady's anomaly. So we have talked about Belady's anomaly in the previous class, which states that with the increase in the number of frames, there will be increase in the number of page faults. So LRU does not suffer from Belady's anomaly. It is comparatively more efficient than other algorithms. So here, because it keeps track of the way how the pages are being utilized over a period of time. Now let us go through some of the disadvantages. So computationally it's very complex because you need an additional process for keeping track of all the processes, all the pages and their utilization, and definitely it's more time consuming compared to that of other processes. Now let us try and understand the working of LRU with the help of a very simple example. Now here I have considered 4 frames and I have considered a page reference string. So as said earlier, page reference string highlights the requirement of pages over a period of time when the program is in the course of its execution. So page reference string is the way how the pages are being accessed whenever the program is under execution. Now as in the other cases like that of FIFO, optimal page replacement, and LIFO, P here is used for representing page, H here is used for representing page hit, M here is used for representing page miss, and F1 to F4 is used in order to represent the frames. Now again I'm repeating here, page hit refers to a condition when the requested page is found in the main memory, and page miss refers to a condition when the requested page is not found in the memory. So page miss is synonymous to page fault. Now let us try to perform replacement using least recently used page replacement algorithm. So I have a 2-dimensional representation where we have the 4 frames, the page miss and page hit being represented. Now here we have made a request for page number 1. So since page number 1 is not available in the main memory, so what I need to do is I need to load page number 1 from secondary memory onto the main memory, and we have a page miss. So after 1 there is a reference to 2, so 2 is also not present, so I need to bring 2 from the secondary memory. There is a reference to 0, so since 0 is not there in the main memory, so I need to bring it from secondary storage to the main memory. Again I have a page miss. Now after 0 there is a reference to 2, so since 2 is also not there, I need to load 2 from the secondary memory onto the main memory. Again we have a page miss. Likewise after 2 there is a request for 4. So since 4 is not available in the memory, I need to load 4 from secondary storage device onto the main memory. Again what we have is we have page miss. Now in case of the first 4, in case of the first 4 pages, we have not performed any replacement because the frames were empty. Now any replacement that is to be performed from this particular point onwards is to be done by replacing either of these 4 pages. So what now, because since here all the 4 frames are exhausted, so any replacement that is to be done, what we need to do is we need to select either of these pages and perform replacement. Now here what we are doing is we are using the concept of least recently used page replacement algorithm. Now after 4 there is a page reference to 8. Okay, after 4 there is a page reference to 8. So now out of 4201 I need to select a page that is to be replaced by 8. So the one that is used at the farthest point in time will be replaced. So out of 4201, 1 is the page that is used at the farthest point in time. So 1 is replaced by 8. Now after 8 there is a request for page number 9. So out of 4201, you see that 4208, you see that 0 is the page that has the farthest reference. So now 9 will be replacing 0. After 9 there is a page reference to page number 5. So since 5 is not there, I need to perform replacement. So out of 4298, 2 is the page that has the farthest reference. So 2 will be replaced by 5. Now after 5 there is a request for page number 2. So since page number 2 is not available in the memory, I need to look for out of 4598 which one has the farthest reference. So 4 is the page that has the farthest reference, so I'll replace 4 by 2. Now after that I have a page request for page number 13. Now since page number 13 is not there in the memory, I need to perform replacement. So out of 2, 5, 9 and 8, right, we see that 8 has the farthest reference, so 8 will now be replaced by 13. Now after 13 we have a page request for page number 0. So since 0 is not available in the memory, so I need to bring 0 onto the main memory by replacing. So out of 2, 5, 9, 13, we see that 9 has the farthest reference, so now 9 will be replaced by 0. Now after 0 there is a page reference for page number 1. So since page number 1 is not available in the memory, I need to perform replacement. So out of 2503, we see that 5 has the farthest reference, so 5 will be now replaced with 1. Now after 1 there is a request for page number 11. So since 11 is not there, I need to perform replacement. So out of 21013, 2 has the farthest reference, so 2 will be now replaced by 11. Now there is a page request for page number 4. So since page number 4 is not available in the memory, I need to perform replacement. So out of 11, 1, 0, 13, 13 has the farthest reference, so 13 will now be replaced by 4. Now after 4 there is a page reference to page number 9, or there is a request to page number 9. So since page number 9 is not available, I'll select the farthest one out of 11, 1, 0, 4. So if you see, 0 is the farthest page, so 0 is replaced by 9. Now after 9 there is a page reference to 11. So 11 is already available in the memory, so we have a page hit. Now likewise after 11 I have a request for page number 12. So out of 11, 1, 9 and 4, right? Out of 11, 1, 9 and 4, I need to select the farthest page. So I need to select the page that has the farthest reference. So 1 is the page that has the farthest reference. So 1 will be replaced by 12. After 12, I have a request for page number 9. So since page number 9 is already available in the memory, so I will not perform any replacement, because whenever there is a page hit, you should not perform any replacement. Now after 9, there is a page request for page number 8. So out of 11, 12, 9 and 4. Out of 11, 12, 9 and 4, 4 has the farthest reference, right? So I need to replace 4 by 8. Now likewise, after 8 I have a request for 5. So out of 11, 12, 9 and 8, I need to check for the farthest reference, and the farthest reference is page number 11. So 11 will be replaced by 5. Then after 5, I have a page request for page number 4. So out of 5, 12, 9 and 8, 12 has the farthest reference, so 12 is replaced by 4. After 4, I have a page request for page number 8, right? So since 8 is already available in the memory, so I have a page hit. So whenever there is a page hit, no replacement is required. So after 8, I have a page request for page number 3. So out of 5, 4, 9, 8, I need to find out the farthest reference. So farthest reference is page number 9. So 9 will be replaced by 3. Now after 3, there is a page request for page number 1. So since page number 1 is not available in the memory, I need to replace some page with 1. So out of 5, 4, 3a, you see that 5 has the farthest reference. 5 is replaced with 1. And after that, I have a page request for page number 0. So out of 1, 4, 3, 8, 4 has the farthest reference. So 4 is now replaced with 0. So we have 1, 0, 3, 8. So this is the way how least recently used page replacement algorithm works. So here the number of page hits are 3, number of page misses are 21. So now I'm determining the page hit ratio. So page hit ratio will be 3 by 24 into 100, and page miss ratio will be 21 by 24 into 100. So 3 by 24 is 1 by 8, so it will be around 12.5, and miss ratio will be around 87.5. So 12.5 plus 87.5 makes 100. So this is the way how least recently used page replacement algorithm works. So in today's class, what we have learned about is we have learned about how LRU performs its operation. We have learned about what LRU does. We have learned about the fundamental reliance of LRU. So it relies on the locality of principle of locality, and we learned about how replacement takes place in case of least recently used page replacement algorithm. Then we discussed some of the advantages and disadvantages of least recently used page replacement algorithm, and eventually we discussed an example that elaborated on least recently used page replacement algorithm in a greater detail. Thank you very much. Have a very good day.